This instruction video explains how to divide the data collected with the VU-AMS device into logical periods for further analysis. We do this with the data analysis and management software that comes with the VU-AMS device. Before labeling your data, make sure the R peaks have been detected correctly and that manual correction has been done on the entire interbeat interval signal. How this is done can be seen in the R peak detection tutorial video at www.vuams.nl. Okay. We now click on the Label Data tab. Here we see the heart rate displayed as a smoothed signal in the top part of the window. And we see the motility or movement signal at the middle part of the window. At the bottom of the window, we see our entire interbeat interval signal again, which will help us to quickly locate our current position in the data. To show you the concept of labeling, we will use data from a guided ambulatory experiment as our example. In this particular experiment, we led people through several conditions inside and outside of the laboratory, in the company of an experienced instructor, while wearing the VU-AMS device. The conditions in this experiment were simulations of a variety of daily physical activities which were all performed during a fixed period of time. Our main mission, to divide the data into logical periods for further analysis, therefore translates to labeling the periods that each represent a single experimental condition. The aim of labeling is to get an average value for each available parameter, such as heart rate, pre-ejection period, respiratory sinus arrhythmia, and so on. And that for each experimental condition. For the current example of the guided ambulatory experiment, a final result and ultimate goal would look like this when finished. The screen shows a colored bar from the start and end times of each condition. The bar is often termed a label. Hovering the mouse over the bar gives us the start and end times, as well as a description of the condition, for instance, resting baseline. To get to this point, we need to basically tell the software which part of the data are to be considered separate conditions. However, before we can actually begin labeling the data, we need to create the blueprint of possible labels for the conditions first. This blueprint shows all experimental conditions in our experimental design. This is done in the label configuration file, or .cfg file. In our example, we need to create a label configuration file with at least one main category, experimental condition. So, in our example of the guided ambulatory experiment, the main category, experimental condition, contains all our condition values, with 10 for baseline, 11 for standing, 12 for lying, and so on. The easiest way to create a label configuration file that suits your purpose is by manually creating or editing a text file. So open Notepad or any other program that can save a text file. A main category is always started with a hash key, followed by the name you want for the main category. In our case, we would write hash key experimental condition. Then each category, in this case the experimental conditions, needs to have a unique value followed by a name for each condition. For this example, experimental condition is our main category and it has 19 category values for the experimental conditions. To create the first category value, place the number 10 for sitting, 11 for standing, 12 for lying down supine, and continue until all values are assigned. When all values of the category are defined, the label configuration file is done. So, save the text file and close it. Save it under a logical name with the extension .cfg. Let's call this label configuration file guided ambulatory experiment.cfg. Now that the label configuration file, our blueprint for data categorization, is ready, we need to make sure the VU-DAMS recognizes these categories. To do this, go to the menu bar, then to Actions, click on Edit Label Configuration, click on Import Label Configuration File, select the label configuration file you manually created and click on Open. When this file is used for a longer time, like for a certain project, click on Set Label Config as default. Now we can start the actual labeling of our data. In our notes containing the start and stop times of each condition for this subject, we can see that the first experimental condition was the baseline of 4 minutes of quietly sitting. This took place from 9:10 to 9:14. So we now place the mouse cursor in the top bar where it says click and drag to add labels. You will see a small time window appear at your mouse cursor. This will help you place the starting point of your label accurately. Then click with the left mouse button in the top bar at around 9:10. Also, a dashed guideline on both ends of the label will appear and will help you eliminate noise caused by movement in between two conditions. In our case, this happens, for example, when we move from sitting to standing. We don't want this transition movement in either a sitting or standing label. Now drag from the starting point of the label towards the right while holding the left mouse button pressed until we arrive at the right dashed line at 9:14. Now release the mouse button. A pop-up with our previously defined categories will appear. We choose from our main category experimental condition the value 10, baseline. Click OK. The pop-up window will close now and a colored bar with the corresponding category value appears. You can verify the information in the label by hovering the mouse on top of it. The second experimental condition was quietly standing and started at 9:14:30 and lasted for 3 minutes. Click with the left mouse button in the label bar above the heart rate window at 9:14:30 and then drag from this starting point towards the right while holding the left mouse button pressed until we arrive at 9:17:30 and release the mouse button. The pop-up with your previously defined categorizations will appear again. We now choose standing 1. Click OK. The pop-up closes and a bar with another color appears, also containing the corresponding category value. Because the conditions in our experiment were performed in the presence of an experimenter, we were able to write down the start and stop times of each condition, and we used this information during labeling, as the UMS data file contains the recording time. But we also pressed the marker button at the beginning and ending of each condition. Shortly pressing the small black button on the VU-AMS device creates marker lines in the data at the exact time the button was pressed. These lines will help us to more easily detect the start and stop times of each experimental conditions. So we can use the marker button, or noted start and stop times, or a combination of both, to make sure we label the correct periods for all conditions. When working with the event markers generated by the event button of the VU-AMS device, you have the possibility to automatically place a label exactly between the two markers. Let's try this for the third experimental condition, where the event button was pressed right before and right after the condition. By clicking with the right mouse button on the label bar between the two lines, we get the option to place a label bar between the markers automatically. A pop-up screen appears like before, and now we choose 12, lying supine, and click OK. Also, you can click and hold the left mouse button on the label to grab it and reposition it. Or click and hold the left mouse button at the beginning or end of the label and drag to increase or decrease the length. If you want to edit or delete a label, just right-click on it and choose the required action from the pop-up menu. Now repeat this labeling until all relevant data is labeled. The data will look like this when finished. We now have divided our continuous data into smaller parts, our experimental conditions. Note carefully that each label represents a row in the Excel sheet obtained under the Label Information tab. Now go to the Label Information tab and wait until it's finished calculating. The first column is the subject name. It has the name that we gave when programming the device for recording. And as said, each row represents a labeled condition, as is identified by the second column, Label ID. The rest of the columns contain values for a lot of variables, like minimum, maximum, and average heart rate during the condition. PEP values are not given in this example, because they were not yet scored under the Impedance Scoring tab. The power spectral values of the interbeat interval are not always present because some conditions were shorter than 4 minutes. Spectral analysis is performed only on labels with a minimum length of 4 minutes. If we pay close attention, we see that there are too many rows with values in the Label Information tab. This is because there is a label ID with the number 0. This label is the average of the entire recording and not the average of all the labels. If you do not want this in your output, you can permanently make sure the program does not show you the label ID with the number 0 in the Label Information tab by clicking on Settings in the menu bar, then Label Information in the pop-up screen, and then deselect Include Label 0 for entire data recording. Click Save Settings. Instead of predefined category labels representing a specific condition, you can also choose to create time-based labels, representing a fixed amount of time. This means you divide the entire recording into predefined pieces that can last in duration between 10 seconds and 1 hour. This is especially useful if you want to generate continuous 60-second ensemble averages of the impedance cardiogram for PEP scoring, instead of a large-scale ensemble average that spans an entire condition. Click in the menu bar on Actions while being on the Label Data tab. Then select Add Time-Based Labels, type in 60 seconds and press OK. And now we have a label for every minute of the data. And because of this, you will get a lot of rows in the Label Information tab. You now have to rely on the label ID and the start time of the label to maintain the chronological order of the labeled minutes in further analysis. For each labeled minute, you get a value for heart rate, RMSSD, and so on. Notice again that some variables have missing values. The frequency analysis could not give a value per label because it needs a minimum label length of 4 minutes. And we created labels with a length of 1 minute. PEP, LV, T values and so on are also missing as they have not been scored in the impedance scoring tab. They can be scored, but the downside is that you have to do this for every minute, in this case 95 times. All other variables will be automatically generated for each time labeled label.